Hi guys, my name is Bob. In this video, I am going to show you a very simple technique to solve all different kinds of area under the curve problems for y is equals to function of x. But before I do so, if you guys like this video, help me press the thumbs up icon below this video to beat the YouTube algorithms and rank this video on the top of the search. And if you guys like integration problems and Maclaurin series problems, don't forget to subscribe to this channel. By following these 4 steps, which I will be showing you in a minute, you will be able to solve all the different kinds of area under the curve problems. So to solve area under the curve problems, what you need to do, the first step, is to identify integration of the function which forms the upper boundary. The second step will be finding the integration of the function forming the lower boundary. The third step will be to find the upper limit of x. And the fourth step is to find the lower limit of x. By using the 4 steps shown, you'll be able to solve all the different kinds of area under the curve problems. Now let me show you by using the examples below. For the first question, to find what is the area under the curve, we will first find the upper boundaries of the area under the curve. So in this case, that will be fx. While for the lower boundary of the area under the curve, that will be the x-axis, which is y is equal to 0. And my lower limit is a, and my upper limit is b. So this is just basically equivalent to the integral of fx from a to b. As for the second question, to find the area under the curve, first thing we find is the integration of the function forming the upper boundary, which is in this case my x-axis is 0. And the second step is to find the integration of the function forming the lower boundary, which is in this case y is equal to fx. The third step we are finding is the upper limit of x, which is in this case my b. And the fourth step is to find the lower limit of x, which is a. So this is actually equivalent to the negative of the integral of fx dx, evaluating from a to b. Now let's take a look at the third question. So as for the third question, we're going to apply the same technique. First thing, we're going to find the integration of the function forming the upper boundary, which is in this case y is equal to gx. And then what we're going to do is we are going to find the integration of the function forming the lower boundary, which is in this case fx. And the next thing is we're going to find upper limit of x, which is in this case b. And last but not least, the lower limit of x, which is in this case a. So basically, to find the area under the curve, we are evaluating from a to b of gx subtracting away fx dx. Last but not least, let's look at the question number 4. So to find the area under the curve for question number 4, we have to split it into 2 parts. The part in which the shaded area is above the x-axis and the part in which the shaded area is below the x-axis. So for the part in which the shaded area is above the x-axis, it is the same as question number 1, which is fx forming the upper boundary of the area under the curve and the x-axis forming the lower boundary, and then evaluating from a to b, because my b is the upper limit and a is the lower limit. So this is equals to the integral of fx dx from a to b. And to find what is the shaded region that is below the x-axis, we will work it out as well. Same thing, applying the technique. We'll find what is the integration of the function forming the upper boundary, which is the x-axis is 0. Subtracting away the integration of the function forming the lower boundary, which is fx. And our upper limit is c, our lower limit is b. So this is just basically equals to the integral of the negative of fx dx, evaluating from b to c. So to find the area under the curve for this particular question, basically we are just adding the 2 together, adding the 2 functions together that we calculated. So that will be the integral from a to b of fx dx, subtracting away the integral of fx, evaluating from b to c. Okay, so basically the point of this video is to show you the techniques of solving all the different kinds of area under the curve following the 4 simple steps. I hope that this video actually helps you to solve all the different kinds of problems, and if you guys like this video, help me press the thumbs up icon so that this video can beat the YouTube algorithms and rank it on top, and more people will get to follow these very simple techniques to solve the different kinds of area under the curve problems. My name is Bob, thank you guys for watching, and I will see you in the next video. Goodbye guys.